Hi everyone, welcome to Global Virtual Summit 2022 and today workshop session in track 2, a necessity in the development trajectory of Bangladesh. Theme 1, transformational education using technology, challenges and benefits. Today topic is effectively designing and implementing qualification framework. I am Dr. Sheikh Muhammad Rasul, Assistant Professor, EC Department, Lord's Institute of Engineering and Technology, Hyderabad, India. I am your moderator today. Today our workshop duration is 2 hours. In that after 40 minutes we will have a break. During break we will take question answer session 5 to 10 minutes and last 20 minutes for question answers. Let me introduce today speaker who is Dr. AFM Saiful Amin, renowned educator and expert in the field of engineering. He is leading proponent and promoter of engineering education and sustainable infrastructure in Bangladesh. He has been teaching and researching as well as designing, constructing, repairing and maintaining installation for over 25 years. He has been professor of engineering in the Department of Civil Engineering at Bangladesh University of Engineering and Technology. Dr. Amin also plays a vital role to improving the quality of education engineering as a vice chairman and the acting chairman of the Board of Accreditation for Engineering and Technical Education of the Institution of Engineering. I request attendees to place any questions in questions tab in Vertex chart. Now I request Dr. Amin sir to please continue with the session.
Thank you. Dr. Rasul. And just to make sure, I don't see any attendees in the presentation. Are they joining or they can see directly?
So they will be in Vertex, not here. In Zoom only, we will be here.
So are they listening to it live?
Yes.
In other rooms?
Yes, sir. You carry on.
Okay. Thank you very much, Dr. Rasul, for the clarification. And this is Saiful Amin. I am from Bangladesh. And Bangladesh is a developing country. And we are also transforming our education system into an outcome-based education, basically also for the engineering education. So it is a necessity in the development trajectory of Bangladesh. And I will emphasize in different ways how it relates to our development trajectory. So here I will show different attainments that we can achieve in our the education process. So as Dr. Rasul already mentioned, my presentation will be in basically 3 parts. In the first part, I will show about the outcome-based engineering education, then some academia and industry collaboration arena. In the second part, second half, about 40 minutes from now, I will move into the engineers in the national development, the roles and ingredients in the development trajectory. Then in the last part, I will show some culminations and takeaways from this presentation. So that's the overall plan of our today's lecture. So first I emphasize on the outcome-based engineering education. So as you see here, engineering education, engineering is the term I could put in the emphasis. So we all know about OBE, but what are the outcomes that we know from engineering? There's the point of discussion today. So if you look at this simple figure, it's a good creation of one artist. But here you see the red stone is known as the capstone, and it forms an arch, and whole arch remains in the compression. And if you remove particularly this capstone, actually the whole arch will fall. So this is the key part, and I will show how we will attain this capstone in our engineering programs. So capstone is not basically unique in the engineering. For example, if you look at the nursing, if in the nursing curriculum also, the foundations are on chemistry, biology, or psychology, and then ethics or nursing the adults and children, and so on. Finally, the capstone experience is coming at the final year of the nursing courses. It's the standard level. So it's a pre-professional level, then level 1, then level 2, level 3, or the final level. And of course, there are some, you see, some additional joints in between the every levels. You see in the different color. What are these? In this civil engineering definition, we call it the mortar joints in arch. And here, basically, we know about the mathematics, art, music, foreign language, sociology, speech, history, English, or study abroad. These are all basically some necessary ingredients for a nurse to become successful in his or her career. So that's the thing. So basically, if we construct an arch, how we construct it? We make a temporary formwork, then we make the arch like this using some stones, and finally we put the capstone, and we remove the formwork, and the capstone remains in place. But again, if we look at this animation closely, basically we are the formwork. The teachers are basically the formwork, and when we move out, our students, the students basically who are the main future of a program, are able to cruise very finely. So in a multifaceted assignment that covers the culminating the academic and intellectual experience is very important, and students in engineering may learn how a professional engineer manages and controls multiple engineering facets for a project from feasibility to completion. And students may be able to understand the art of integrating the disciplines in a single project. So here I emphasize the term, understand the integration. So integration is very important, and I will explain it in the subsequent slides. And I explain, for example, the engineering part and also the culminating part. So these are basically my basic point of discussion. So here basically coming around the role of academicians. We, the engineers, are preparing to brace the industry needs. So basically, we have to understand what the industries really know, and what the industries really want, and what the industries really can get from us. So basically, we cannot have any misfit between the academia and industry. If we think it as a bridge, then and it's a prosperous future, our engineers should be able to cross this bridge with the people, and it is a continuity for a prosperous future. And we together need to go to the people to know about their needs, how those needs are met by the engineers, and how do they think about our creations, and how they evaluate us. And finally, we will see how they live in a prosperous future. So these are the major objectives of an engineering education. So when I studied a long time ago in Bangladesh, we had a conventional 4-year program where basically we studied, and then we graduate and then work. But here basically now we are changing this structure, and we are bringing the industry right on our curriculum. So in around 3rd-year courses, we make the internship or knowledge application, and then we have our 4th-year courses where in engineering, where our industry staffs can interact with our students, and thus our students can become a ready contributor, and when they graduate, and they can upskill, and they become a value-added contributor in the future. So that's the point where we make the changes in our curriculum. So we all know about the peak, the Mount Everest, the Himalayas. It is the highest peak, and also somehow it relates, looks like our Bloom's taxonomy. And you see some mountains are obstructing the whole view of this peak. But if you want to go to this peak, nobody alone can basically go. They usually take the help of their fellow friends. So that means we need to know how to have these difficult climbs. So basically in our engineering program, we also need to provide supplemental oxygen or supplemental support through our mentors who can help us to breathe during this very hard climb in their career. So these are the very important parts. So basically I am a structural engineer, so I know little about structure. And in capstone project, you see that the structure is stabilized using a capstone I showed you. But in education, the capstone is a synonym where we provide the students with the curriculum experiences and in their final year study. So this is the way we correlate. And this correlation in education is very important. And without having the perceptions of a complete picture, individually learned skills may only be enable a student to apply his skills with less effectiveness in a real world project with full of complexities. And program outcomes, the most important part in our OBE, outcome based education, cannot be achieved and measured reliably without learning from such a course. And engineering accreditation bodies now take offering a capstone project course as a criteria for the accreditation. So these are the basic takeaways for us. So what could be the attainments basically in our engineering education? Basically, we all know the books and the bookshelves. Of course, we now have tabs and we have e-books, but these are also the bookshelves, maybe in the virtual world. But apart from the bookshelves, basically, we need to know about the skills and attitudes. So the skill basically encompasses the creative thinking, problem solving, social and emotional aspects, rapport and fellow feeling, communications and lifelong learning. And in terms of attitude, we know that collaboration, passion, growth mindset, dissatisfaction with the status quo, willingness to take risks and fails, and can do spirit. These are the major important parts. We know that can take any of us from a corner place with only knowledge to a centroid place with skills and attitudes. So these are very important parts, skills and attitudes that we need to know. So the plant that we are looking at today is the future of the country according to the precise master plan. So this is the difference between a single plant and a good garden and well-planned garden and the forest. So this is the basics of the mega infrastructure. And a planned integration, again, I emphasize on the part integration of today's mega projects will pave the way for the tomorrow's mega infrastructure. So these are the basic concepts of the outcome-based education. Very recently, we opened one of our largest project in Bangladesh, the Padma Bridge, and it was a dream and now it is a reality. But basically our peoples are larger than our dreams. So this is the point where we move in forward. The wheel of prosperity actually are geared through the people's diversified skills. Every people does have individual skills and we need to integrate those skills to move the gear in a timely manner. So this is our basic vision, and a relation is required between the income and expenditure. So we have to know about all those things to move forward. Again, you see that every countries of the world are basically connected and connected with some global market. If we look at the case of Bangladesh, it's a local market. Of course, we have a domestic market, but we also do have international market to bring in some commodities and export some commodities. So there are strong interdependence. For example, in the construction industry, the local garments industry, ship industry, and the blue economy, for IT sector, pharmaceuticals, health sector, education and research, and global economy, international trade and tourism. So these are the areas where basically we interact with each other. And here basically there exists a lot of functional integrations. And in the age of fourth industrial revolution, actually there is no scope for isolation. The fourth industrial revolution is basically asking us to get connected physically and also virtually. And physical connection is required for our freight transport. We cannot virtually export the goods or commodities. So road, rail, sea or air communications are the cost effective and efficient. And this can be done through the information technology. So that is virtual. So again, we have to integrate the virtual communication with our physical infrastructural communication network. And this way, basically, we can have the supporting strengths and from each other. As you see, this is a famous photograph that early technologies took a lot of time to get popular, but nowadays the virtual technologies are easily penetrating our day-to-day life, and we are getting connected as well. This is also a big integration that the our this great seminar of taken by Info OBE is taking out. And here, if we bear the cost of a back seater, and we cannot bear the cost of a back seater, and we have to move ahead with a well-defined strategy. So that's the major point. And finally, all of you know, the South Asia is very famous and very well known for the agro-based economy, and efficient communication system can change the fortunes of our product producers, the agricultural producers, the farmers, and the related industry. And basically, agriculture is no longer a domestic product, and agricultural ingredients and the products are all now becoming international. So again, interdependence is the most important thing. And ensuring the fair price of crops is an indicator of the economic progress. And here we are striving a lot. And Bangladesh is famous for her rivers, and rivers from the Himalayas create the potential of our soul to the ocean. And we need to transform this potential into reality from the blue sea. So the Bay of Bengal is the great part where we can contribute. But how to integrate all those things in a comprehensive development plan? Basically, our future engineers will have to do it. And we have to do it with our world knowledge in engineering. So that's the major part, and integrated development is required for the riverine and the coastal areas. And bridges are no longer just means of communication, and bridges now also the tourist attractions around the world. So we are working around it. And as you see, the roads and waterways are basically the railways and everything are coming into the same plan. And you see now the new technologies are available to build new islands in the blue waters, and man-made islands can increase our land. And but again, this requires some integration, and where the engineers have to play the role. And again, if we have the manpower, they can build the nation, they can build the world. So so these are the influencing factors for the future success of our country. So in this way, basically, we define our engineer with the 12 attributes. First 4 is basically we all know, and we know in very detail. For example, the engineering knowledge, problem analysis, design development solutions, and investigation. But the rest 8 are less common, but we have to attain all those 8 also in a vivid manner. So first is the modern tool uses, then the engineer and the society, environment and the sustainability, ethics, individual and teamwork, communication, project management and finance, and lifelong learning. So these are the major part that our engineers have to meet. And apart from it, basically, I will focus more on the further activities. Those are basically known as the complex engineering problem and complex engineering activities. So these are here listed as the modern tool uses, individual and teamwork, engineer, society and environment and sustainability, ethics, lifelong learning, project management and communication. If you move into the range of complex engineering problem around it, basically first will come as the depth of knowledge, then the range of conflicting requirements and depth of analysis. Then again, familiarity of issues, interdependence, extent of stakeholder involvement and conflicting requirements, and extent of applicable codes. So these are the ways where actually our engineers require to display the outcome-based education and their attainments in a great vivid way. So, and also we need to show a range of complex engineering activities. So we have to know about the range of resources, level of interaction, innovation, and consequences for the society and the environment, and also the familiarity of the issues. So these are known as the complex engineering activities. These are also a very important requirements to achieve a best output from the outcome-based education. And it is really a necessity of the accreditation. So I arrived almost at the first 1/3 of my lecture, and where I covered the relation of the outcome-based engineering education with the academia and industry. So in the next part, basically, I will show some of the examples where the engineers can integrate their knowledge in the national development, and what are the ingredients, basic ingredients there in the development trajectory. Thank you very much for your attention, and I hope you will remain with us and proceed to the next journey. Thank you. And I take 5 minutes break, and during this break, as moderators permit, we can take some questions. Okay, now I start my second part of the presentation, where basically I'll show the need of appropriate outcomes from the engineers in a national development scenario. So I show from the complex engineering problem, the highest level of attainment the engineers should display. So there are few ingredients in the complex engineering problem that one has to know. So these are basically interpreted from the civil engineering perspective, where basically my subject is the infrastructure development, particularly in the civil engineering areas. So first thing that we require in the outcome-based education in engineering is to allow a fundamental based analytical approach in our problem solving. If you know a pothole in the road and you have to solve it, and you can put some measures on the top of the road to fix it. But basically, you have to know the whole scenario under the road if you want to stop the repetition of finding out the potholes always and in the future. So if you need a permanent solution, basically you have to start from the very big, deep inside, and you have to evaluate it in a deep way. And for example, if you go for a construction in a road network, and of course there were some utility lines beneath it. So now, of course, the road will give you some additional benefit. As a user, you will receive it. But what will happen to the obstructed utility lines beneath it? So you have to identify it, and you have to have your own measures to relocate it. So you see that there is some wide range or ranging or conflicting technical and engineering and other issues that spark your activities. If you can assess all these scenarios in future engineering activities and in the construction, then you can become a successful engineer with positive outcomes. So this is the one scenario you have to understand. So the wide range of conflicting and technical engineering and other issues has to be solved by an engineer at the complex engineering problem solving level. And sometimes, for example, if you construct an underpass, maybe you require some abstract thinking or originality to analyze and formulate some suitable models. If you want to construct a bridge, or if you construct a building, actually there, of course, there is no obvious solution, and you have to solve it from the abstract thinking and original conclusion. There are a lot of varieties of building and problems will come across your table, but you have to give unique solution to it in a best possible way. So it also falls into the range of complex engineering problem solving. And of course, when our students read from the book, they read some familiar problems, but in the practice, they will encounter lot of unfamiliar issues in their whole career. It can be a bridge, it can be an expressway, or it can be a very magnificent high-rise building, skyscraper, and they have to formulate it from the design table to the reality. So this has to be very carefully dealt with, and our engineers show their outcomes in the appropriate level to solve these unfamiliar issues. So it's not a simple arithmetic or it's not a simple algebra, but you have to know it carefully. And of course, we know different standards and course of practices for our solution. But basically, we have to be capable to solve it from the very first fundamental principles. We cannot forget the fundamental principles because our codes and standards are, of course, based on the fundamental principles. But basically, these gives us a simple, straightforward solution. But in most of the cases, our solutions are not that straightforward. We have some subset of easy solutions, and we have lot of sets of complicated solutions necessary in a project. So where we have to be able to solve it very carefully. Then in engineering particularly, we involve diverse group of stakeholders. If you see a underpass under a road, busy road, you will see the road across above you is being used by a lot of peoples of diverse economic groups and societies. And of course, there are a lot of people are also using the underpass beneath the road. But you have to be carefully chalking out the necessity of each of the societal groups and their varying needs. And our project has to serve all those needs very delicately. And of course, in our project, there will be many components and sub problems. As I told you, you may need some electric fans and electric illuminations in the underpass. That may be easy or that may be complicated depending on the problem. But there might be some more complicated issues you'll be solving. For example, a structural solution or a geotechnical solution, or maybe a transportation solution. So there are some interdependence between the different varieties of engineering and to come out with a successful project. And of course, we need to involve the use of diverse resources. And for this purpose, resources include basically people, money, equipment, materials, information, and also the technologies. And here, basically, if we construct an underpass under a road, we need technologies to construct it when the cars are moving above it. So in that case, we may need to import some of the technologies from abroad, and sometimes we have to develop our own technologies and design our own technologies within our own country. So these are the ways we can come out with a successful solution. And we need to have deciding about the level of interaction. For example, we require resolution of significant problems arising from interactions between wide-ranging, conflicting in technical, engineering, and other issues. For example, if you construct a building, it's a small building with a small basement, or it's a large building with a large basement. Of course, how tall you can make this building. Maybe there is an airport beside it, and maybe you have to encounter the problems of civil aviation restrictions when you go high. So these are the issues will be coming out, and you will have to have technical issues, engineering issues, and also some social issues. And so these are the things you have to deal. And finally, innovation. You can have the innovation at the maximum topmost level. So sometimes, for example, if you develop a monument and you can give life in it using some good example of hydraulic fluid mechanics or hydrodynamics. But you have to have, therefore, some research-based engineering knowledge and its application in the novel ways in our engineering principles. And sometimes the consequence for the society and the environment. When we are constructing flyover, sometimes we can close the road permanently for a few days, or we can keep the roads open and make the construction above it. Both are possible, but all scenarios has to be considered based on the cost and the construction time. So these are the issues where we have to be able to predict the difficulties in the design, in the construction, and also the future use, and also the mitigation procedures. Very important. And of course, we are encountering the problems. And we have to, once we have constructed one bridge, and in future we'll construct another bridge. But basically, we have to be able to applying the principle-based approaches based on our past experience in our future endeavors. So we have to be able to interpolate the problems, and we have to be able to extrapolate the problems. Of course, interpolation is easier, but extrapolation could be more difficult, and our engineers will have to be able to be familiar with all those things based on their past experience. So our goals is that some of the lessons we learn from our mentors may bring some food for us in our profession and some praise, but the deeds we accomplish based on those lessons may lead to social emancipation in our country and world at large. So we think big, and we think for our country, we think for the world, and we think for the humanity. And higher we reach, the vaster our responsibility. So our deeds should be the best, and we can accomplish for the humanity. And we can never forget this, as every religion even encourage this greatly. So what will you have to learn from it? Basically, we detail out the courses based emphasizing on the planning, analysis, and design, then application of the civil engineering theories, then diverging civil engineering and cross-disciplinary knowledge to prepare our contract documents and tender documents, and students need to present their projects and submit the projects and reports at the end of their work. So in that way, different facets of civil engineering may be taken care of. For example, structural engineering, or environmental engineering, or transportation engineering, or geotechnical engineering, and maybe the water resources engineering as well. So different facets can culminate to the topmost peak of a pyramid, and we call it the capstone as well. In a metro rail project, for example, we are having a lot of strategic plan for our transportation system, but of course it does have different branches of transport engineering together. For example, in a metro rail project, transportation engineering lies at the top, but of course it is supported by the structural engineering, the pier and the girders, and then founded on the geotechnical engineering. Now, of course, the environmental concerns are also addressed. So that's why we call the top part as the superstructure and the bottom part as the substructure. It's also a great art of integration. So we have a physical environment, environmental quality, and the biological environment, and socio-economic environment. So these are basically the broad-based environmental baselines we have to think about. Again, we can have the cost, we can have international counterpart, but we have to thought about the social feasibility. Different people, old and young, and different groups of age groups will use a metro project, but the social feasibility is as important as the economic feasibility. Otherwise, this cannot make the project the best benefit out of it. So again, I emphasize the major slides, the range of complex engineering problem. Here I explained about the depth of knowledge required, in range of conflicting requirements, depth of analysis required, familiarity of issues, interdependence, extent of stakeholder involvement and conflicting requirements, and the extent of applicable codes. And complex of engineering activities include the range of resources, level of interaction, innovation, consequences for the society and environment, and the familiarity of issues. I have explained all those things to you. I think it gives you a great insight onto the problem you have to think about. So in a stages of the project cycle, basically we start from the feasibility study where we have to think all those things, all the major aspects, then the project approval process, and then the detailed design process, then the procurement processing and the contract award, and then the project implementation. So there will be some project proponents, there will be some consultants, there will be some supervision consultants, and there will be some contractors. There can be one consultant or one contractor, or can be multiple. But again, this will have go to a proper process of integration. So fundamental steps in the engineering design basically starts from the general planning, then preliminary design of alternate solutions, then the solution of alternatives, final design, analysis, redesign and reanalysis, and then the construction. So this is basically our the second part, and then we know we have to know our the grand plan, what we look ahead, and we have to look ahead at the future, and we need to have a futuristic vision, and we'll be building the future. The engineers will be building the future with all stakeholders in a country and all the groups of people that belongs to a country or the region or the world. So how we plan? So this is the grooming area. For example, in my department, we are designing the capstone studios, where basically our students can have. We are having small office room environment or small design environment where they can learn. So we talk in groups and we talk in persons, and we develop communication skills. So this is one of the imagination of a work group environment where they can work together, they can connect with the world with a little window and also a virtual window. And this is the way how we can get communicated with our educators and our industry at home and with the rest of the world. So this is basically some way where our students will work, and basically the teachers will remain outside, but will only intervene when they need our support. So this way we basically move forward and move ahead. So faculty mentors are assigned to guide, and we also go for the possible industry exposure, physically or virtually. And our academic mentors are coming from environmental engineering, geotechnical engineering, structural engineering, and transportation engineering, each of the engineering backgrounds in a capstone project. So in a group of students, we divide it into 5 to 6 or 7 numbers depending on the situation, and they actually lead. We don't lead. They lead. They also choose a team leader and also a deputy team leader for their group and they select the project, or they are assigned with a project. It's a comprehensive infrastructure development project, and they define the role of each member, including the team leader and deputy team leader, and all members must play active role, and team leaders will ensure this, and choose a select or topic of capstone project and prepare a proposal 1 to 2 pages, and then this proposal is approved by a committee. So this way basically a capstone project rolls in. So again I come to the bookshelf, but basically this bookshelf is the basics of knowledge, but through such capstone experience they are able to show the skills and attitudes. So it's a great part and honor for them to go into the main future work experience by grooming at their final year of their engineering courses. So of course in the Bloom's taxonomy, they have to remember a lot of things. They have to understand many things. They apply many things, analyze many things, evaluate many things, and create many things. So combining all those parts make a new as a whole. So Bloom's taxonomy is there, and they go for creation, and of course they also evaluate and analyze, and other things are remaining for them. So in the outcome, basically you see that remember, understand, and analyze. These are basically level 1, level 2, and level 3 courses coming up. but in the level 4, we expect our students capable of applying more of evaluating and more of creating. And here the capstone project stands as the culmination where they go up to the level of complex engineering problem solving. So in our assessment, we have project report, we have presentation, we have viva, and we have jury. So in that way, they can go into a lot in the whole process, where we can know about their communication skill and their attitudes and everything. And they also have ample choice options to improve them within their course, so that they can have a ready contributor to the national building activities. So as you all know, that the machine is not basically as important as the man behind the machine, and intentions, emotions, and spirit that guide the use of technology is very important. And of course, as I always tell, we have to be able to appreciate why an airport terminal is different from a cargo complex. Both have the runways, but one has to have the efficient passenger handling capacity, and another one also has to have efficient cargo handling capacity. So in that way, the outcomes from the both of the airport terminals are different, and our future engineers will be understanding it in a better way if we go for outcome based education. And of course, safety is a mandatory requirement, but safety concern is different in a chemical lab, or in a construction environment, or in a hazardous environment. So our engineers will be better knowing all those things in the coming days. And of course, lifelong learning. Whatever I learned some years ago are not applicable nowadays. So in that way, to remain competitive with the society, I have to learn. We have to learn, and we have to remain updated with the new developments. One time we used drawing boards to make the drawings, but now we draw in the digital spaces. So in that way, you can see if we are not teaching our students for the lifelong learning, whole attitudes will be falling behind. Of course, some of the things are always there. We use small hand fans in the Indian subcontinent or in Bangladesh for in the hot summer days. And of course, we also have electric fans with the motor and the electricity, and some air coolers when we integrate the coolant. So integration processes are always there, and these are very much successful. And of course, we are having different options of our in our society. We can have clay pot, we can have some water bottle, and we can have some cans for drinking. But we have the growing cities, and we have the competing demands, and our engineers are the vanguards of the changes. And as I always say, that differentiation is very easy. I think almost all functions can be differentiated, but all functions cannot be integrated. So integration is the key word in all respects of engineering work. And we have to be able to integrate all the works so that we can have the best outcome. So in that way, our future engineers will link up with our regional stakeholders in order to get integrated and connected. So what is the best solution? Of course, the first solution, as you see, is totally incompatible, but this can be done or this can be done. I don't know which one, we don't know which one is the best, but maybe the both will be working in the different scenarios. So we have to know the workable options. And of course, we need to know the law. And in future, lawyers with engineering knowledge in architecture, planning and specification and surveying will steer the whole world. And we need to scale the ladder of progress. So of course, we cannot jump so fast, but we have to jump step by step. So these are the ways we can go towards attainment of knowledge, skills, and attitude together. So we need to recruit more people to join the procession of innovative engineers. So these are all from me. So I finish here, but at the same time, I think we can have couple of questions, and we have couple of minutes also with us for discussion. Thank you.